Hello students, in today's session we are going to discuss the sorting techniques which are present within your syllabus, programming for problem solving. So first of all, let us see what is the sorting. So sorting algorithm is very much important concept when we are doing the computer applications, as it is one of the concept of rearranging your data in a particular logical order with the help of comparing multiple elements. So when we maintain a collection of data, many applications call for rearranging of data. It is not always necessary that whenever you enter your data in a random order and you just read or consider that particular data in the same order. So many times it is required that your data must be arranged in a proper order, in any logical order. So we have two logical orders, that is either ascending or descending order. So by default the order which we consider is the ascending order. We arrange the data in ascending order. So sorting refers to arranging a set of data in some logical order. So if we have this unsorted list, that is we have taken input and numbers are taken in random order. So if it is required to arrange your data in ascending order, so first of all the minimum element should come, then number larger than it, then largest, and at last we have the largest element within the list. Means starting from the smallest one we have to reach to the largest in a proper sequence, that is your ascending order. And in the similar way, if descending order is required, in that case what is the situation? We have to reverse the concept which is followed within the ascending order. Starting from the maximum value, we have to finish it off till the minimum one. So here we have the sequence 27, 25 till 12 and 10. So starting from the maximum, we are going toward the minimum value, and in ascending order, starting from the minimum, we are moving toward the maximum value. So in our syllabus, we have three types of sorting techniques, that is bubble sort, selection and insertion sort. So one by one, we are going to discuss all these three sorting techniques in detail. First of all, we have bubble sort. So bubble sort, it is one of the simplest technique that works by repeatedly swapping the adjacent elements by checking their order. Means each and every time adjacent elements, order of adjacent element is compared, and if order is wrong, then swapping is done. If order is correct, then we move towards the next two adjacent elements, and this process will repeat until and unless we have a sorted list. But this algorithm is not suitable for the large data set, as each and every time we have to compare the adjacent elements continuously, and if the data set is too big, in that particular case that comparison will take a lot of time. Although it is the simplest technique, but not suitable for the data set which is large enough. So for a small data set, we can consider the bubble sort. So now let us see how bubble sort works. Let us assume we have an array 5, 1, 4, 2 and 8. So what we are going to do in the first pass, what we will do, we will start with the first two elements. So first two elements we have 5 and 1. These are the first two adjacent elements present within the list. Now we compare 5 and 1. The logical order of 5 and 1 is wrong, as 1 comes before 5. As we have said that by default the order is considered to be in ascending order. So we are considering here ascending order only. So logically, if we see this particular order, that is 5 and then 1, is logically wrong when elements are to be arranged in the ascending order. So correct order is what? 1, 5. So it means these two adjacent elements are compared and checked whether the order is correct or not. If order is not correct, in that particular case, we swapped the elements and rest of the list will remain same. Now next two adjacent elements will be compared. Next two adjacent elements means 5 and 4. Now 5 and 4 are compared. So again check the logical order. The order is again wrong. It means swapping is required here also. So we will swap the elements. What we will receive? 1, 4, 5, 2, 8. Now again next two adjacent elements, that is 5 and 2 are compared. Again look for the order. Order is again wrong, which means swapping is required again. So the next we get this list. Next two adjacent elements are 5 and 8. Again check for the logical order of the two elements. 5 and 8, these are properly arranged. There is no we have the correct order of 5 and 8. So there is no requirement swapping here. So the final list what we get after first pass is this. That is 1, 4, 2, 5 and 8. This is your complete step 1. In step 1 what we achieved? We achieved the maximum element at its correct position. So here 8 is at its correct place now. So in the second step, the same process will repeat, that is comparing of two adjacent elements and checking for the order, and if order is not correct then swapping is done. If order is correct, no swapping is required. This complete process will be repeated for the n minus 1 elements, because nth element is at its correct position. So this is your complete pass 1. So what we have said, it is the first pass or first step of the algorithm. Next, within the second pass, the first 4 elements, that is 1, 4, 2, 5, these are taken into consideration. Again, first of all 1 and 4 are compared. Order is correct, so there is no need of swapping. Next, after this, what we receive? 4 and 2. Logical order is not correct. It means swapping is required. So we swapped the elements. Next two adjacent elements are 4 and 5. Order is correct. So there is no need of swapping. And last 5 and 8. Again order is correct. There is no need of swapping. So this is complete pass 2. Here we found the list as 1, 2, 4, 5, 8. Again in the third pass, although we can see that we have a sorted list of elements, but system will not recognize it here. It will repeat the process until and unless all elements are compared and sorted. So the algorithm needs one whole pass without any swap to know it is sorted. So within the third pass, it will repeat the process again, although the list is sorted. Again, here we can comprise it of total number of elements are taken. Each and every element is compared one by one and then swapped as per the requirement. If the logical order is correct, there is no need of swapping, but if logical order is not correct, elements are swapped. So here we can see the algorithm for bubble sort. So for steps 2 and 3, we have to repeat. Within the for loop 0 to n minus 1, what we are setting? We are setting the j loop. J loop is set from 0 to n minus I minus 1. And within this j loop, what we are doing? We are comparing the adjacent elements of array. That is, if array j is greater than array j plus 1, then we are exchanging the elements. Otherwise, we are keeping the element as it is. Here the loop I is responsible for the change of pass and j loop is responsible for the swapping of the elements of the adjacent elements. We can better understand this with the help of the program here. So, what we have taken, we have declared an array A of 20 size. Next, we have I and j for loop. N is the total number of elements. Next, we entered the size of array. So, size of array is what? It is n. So, let us assume the size of array which is entered by user is 5. So, total 5 elements are being entered by the user. Now, for each and every time, that is for 5 times, user will input the array and data is going to be stored in array AI. Now, for I is equals to 0 to less than n, which means 0 to n minus 1, because total elements are how much? N minus 1 elements are present within the list. So, for n minus 1 element, what we are going to do? We are comparing the adjacent elements and checking the order. Either they are logically in ascending order or not. So, for j equal to 0 till n minus I minus 1, if aj is greater than aj plus 1, we are doing the swapping. Let us take an example here. With the help of example, we are going to execute this program. So, let us take the example as 5, 4, 1, 8, 3. If these are the 5 elements which are being entered by user, so initially I is what? I is 0. So, when I is 0, we will enter into the loop because condition is true. We reached at j loop. J says j is 0. Now, check the condition. J is less than n minus I minus 1. What is n? N is 5. Value of n is 5. So, 5 minus I is what? 0 minus 1, that is 4. Condition is true, means this is initially 4. J plus plus. What we are doing? We are comparing aj is greater than aj plus 1. Initially j is 0. So, a0 is greater than a1. This is 0, 1, 2, 3 and 4. So, a0 is greater than 1. Condition is true or false? We can check. A0 is 5, A1 is 4. So, 5 is greater than 4, which means this condition is true. So, what we are doing? We are swapping the two elements with the help of third variable. So, T is equals to AJ. J is what? 0. So, T is equals to A0. A0 is equals to A1 and A1 is equals to T. So, T is what now? T is A0. A0 is 5. So, T is having value 5. A0 is updated by A1. A1 is what? 4. So, it means now A0 is having value 4. And finally, A1 is equals to T and T is having value 5. So, A0 is now 4 and A1 is now 5. Means we have swapped the two elements. What is the new list now? List is 4, 5, 1, 8, 3. Correct? Again, check the condition because J is updated. J is again true. J is updated. Now, J is 1 and it is less than 4. So, again the process will repeat. So, if A1 is greater than A2, A1 is what? 5 and A2 is what? 1. Again condition is true. Swapping will be done. After swapping, what we will receive? We will receive 4, 1, 5, 8, 3. Like this. So, in this way, the sequence will be done. Each and every time the process is going to be true, the process is repeated. How much time? Till J is true. when j gets fail, when j will become false, after that I is incremented by 1, and again we will go into the loop. So I is responsible for the path changing, that is number of steps, and j loop is responsible for the comparison of adjacent elements and deciding whether to swap the elements or not. So when we discuss about the time complexity of bubble sort, it is O of n square for the worst case, and for best case it is omega of n. Next we have selection sort. Just as bubble sort, selection sort is another sorting technique which allows array to be in sorted order. We arrange the elements in a proper order. But the technique of selection sort is very much different from the bubble sort. In selection sort, each and every time we are finding out the minimum element and looking for the smallest element within the remaining list. In bubble sort, what we are doing, we are comparing each and every adjacent element each and every time in every pass. But in selection sort, we are assuming that this particular element is the minimum one, and with the help of that minimum element we are looking for the element which is smaller than the assumed one. If our assumption is correct, then there is no need of swapping, but if our assumption is wrong, in that particular case swapping is done. So here we can see it with the help of example. Let us assume a array having elements 64, 25, 12, 22 and 11. So what we are going to do, we are assuming that this first element which is present at 0th index is the minimum element. So 64 is assumed to be at minimum position, minimum element. Now we look for the smallest element within the list. So first of all, 25 is considered. 25 is smaller than 64. It means minimum element is what? 25. Now 25 is compared with 12. Again 12 is what? It is minimum than 25. It means minimum is 12. Next we have 22. But 22 is not less than 12, which means minimum element is still what? It is 12 only. Next we have 11. 11 is again smaller than 12, which means minimum is 11. So as per our assumption, minimum element was 64, but we found 11 as the smallest element which is present within the remaining list. So we will swap these two elements. So in the second pass, what we will get? We will get 11 at the first position and 64 at the last position, because these two elements are being swapped. Now next element to the 11 is assumed to the minimum one, means now this 25 is assumed to be minimum element. Now same process is being repeated. Same process means again we will compare for 12. 12 is minimum. Next 22. 22 is not less than 12. It means 12 will remain minimum. Next we have 64. It means 64 is not minimum than 12. Means what we found? We found 12 is the smallest element which is present within the list. So what we do? We will swap these two elements. So after swapping, what we'll receive? We receive 11, 12, 25, 22 and 64. In the third pass, the element which is present at next position is assumed to be minimum. Next, in the fourth pass, element which is present at fourth position is assumed to be minimum. So in this way, the number of elements are assumed to be minimum and looked for the smallest element which is present within the remaining list. If the assumption of the user or the programmer is correct, then there is no need of swapping. We will move to the next pass. But if assumption is wrong, in that particular case, swapping is required. Swapping is done and then move to the next pass. So here we can see the algorithm. So first of all, we have set minimum to the 0th location. Now we are searching for the minimum element within the remaining list. Now swap the value at location min. If we are finding out the minimum element within the remaining list, in that particular case there is need of swapping. After that, increment minimum to point next to the element. Next position will be considered as the minimum, and again process is repeated. So in this way we are going to repeat and finding out the minimum element, and at last we receive an array which is in sorted order. Here we can see it with the help of exam program. So what we have till here, we have declared the array, we have taken the minimum position, Tij variables for swappings. Next we have taken the size of array from the user. After that we have taken elements within the array ai. Now for each and every time I is incremented till size minus 1 for 0 to n minus 1. What we are doing? We are assuming the first, that is index value, to be the minimum element, and within the j loop we are comparing and looking for the minimum one. So for example, if I consider an example 5 4 1 3 2, if this is the list which is being entered by the user, positions are 0 1 2 3 4, these are the index values. So I is initially 0, which means this is minimum. Now for j is equals to I plus 1, means we have to find out the minimum value within the rest of the list. That is why we are starting j from I plus 1 till less than size. Now what is done? I is equals to, j is equals to I plus 1, that is 1, j is 1 now. So a min p, that is a0 is greater than a1. Condition is true. A0 is what? 5 and A1 is what? 4, which means min P is J. What is the value of min P? Now minimum value is 4. Again J is compared. J is now 2. So starting from 2, J is 2, A min P. Min P is what now? That is 1. So A1 is greater than A2. Condition is what? Again true, which means minimum is 1. Again check the condition. So in this way we are repeatedly comparing the element and finding out the minimum element. So after receiving 1, what will happen? J is increased, but value of min P will not be updated because if condition is false. So when if condition will be false, min P will remain at 1. So here T is equals to AI, I is still 0. So T is equals to A0, A0 is what? 5. AI is equals to A min P is what? 2. So A0 is equals to A2 and A2 is equals to 5. In this way we are going to swap these two elements. So after swapping we can print the desired result. So as far as the complexity of the selection sort is concerned, worst case complexity is O of n square, best case is omega n square and average case is theta of n square. Next we have the last sorting technique, that is insertion sort. What is insertion sort? As the name suggests, we have to insert the element at its correct position. There is no concept of swapping here. We are inserting the element at its correct position. For example, when we play cards, what we do? We arrange the cards in a proper sequence, and what we do? We pick a card and look for its correct position and insert the card at that position only. So, that is insertion sort. So, here also we are picking up the element and inserting at its correct position after finding out its correct place. So, let us see the working of insertion sort. We have an array of 12, 11, 13, 5 and 6. It is being assumed that the first element of the list is at its correct position, which means we can say that 12 is at its correct position. So, what we will do? We will compare the second element, that is 11, with 12. So, we can see that 11 is less than 12, means correct position of 12 is after 11. So, what we will do? We will copy the content of this value in some variable. So, let us assume x is equals to 11. We have stored this value x and we will copy this 12 here. And after that, we will keep this x here. So, what we did? We copied the content of the variable into its correct position. We didn't swap, we copied the content. Next, after this step 1, what we receive? We receive 11, 12, 13, 5 and 6. So, there is no need. Now, next 13. 13 is compared with 12. It is okay. There is no logical order difference within here. 12 should come before 13 and it is written in correct order, which means there is no need of copying data to some other variable. After that, we have 5. Now, look for the correct position of 5. So, 5 is firstly compared with 13. 5 must come before 13. So, first of all, we will copy the value of this particular index to some other variable. Let us assume x is equals to 5. We have saved the data, that is, we have picked the data. After that, we copy 13 to the place of 5. We are copying 13 here. Next, 5 is compared with 12. 5 must come before 12. So, again we copy 12 at the place of 13. Next, 5 is compared with 11. Again, 5 must come before 11, means 11 must come at this position. And after that, we will transfer this 5 here. So, what is going to be the list now? We receive the list 5, 11, 12, 13 and 6. Lastly, we have 6. Same process is repeated. 6 is compared with 13. We can see that 6 must be present before 13. So, 6 is first of all saved to another variable. Then 13 is copied here. After that, 12 is copied at the place of 13. Then 11 is copied at the place of 12. And after that, 6 is compared with 5. 6 must come after 5, which means correct position of 6 is this. So, after this, we receive 5, 6, 11, 12 and 13, which means list is in now sorted order. So, what is the algorithm for insertion sort? So for I is equals to 1 to n minus 1. Why starting from 1? Because it is being assumed that element which is present at the first position is at its correct place. So we are assuming it to be at its correct place. That is why we are taking I from the 1 till n minus 1, that is maximum number of elements. Next we have key is equals to AI, that is each and every time we have to pick element from the list and store it in some variable. As in our example we are using X, in the algorithm we are using key. So we are storing the particular data within the key variable. After that j is equals to I minus 1, and while j is greater than equal to 0 and aj is greater than key, what we are doing, we are copying the contents. aj plus 1 equals to aj, we are copying the contents of aj to aj plus 1 and reducing the value of j. And at the last, when all the values are copied or shifted to the right, what we did? We did aj plus 1 equal to key. We inserted the required, the picked data at its correct position, at its correct place. That is insertion sort. So I hope all sorting techniques are clear to you all. So in the next lecture, we will discuss some more complex topic. So the question may come in the exam that what is insertion sort, what is its complexity, or what is selection sort or bubble sort, and you have given with the list of element, you have to search the element or sort the element using the particular sorting technique. So I hope the topic is clear. Thank you.